Okay, this is sort of a shakedown for all of the current skeleton utility features. I'm just going to dive right in here. The first thing I'm going to show is the functionality of the SkeletonUtility submesh renderer. And this is a way to merge elements of your scene graph, such as the sword here, which is actually a Unity sprite. It is not part of the spine skeleton. In between slots in the draw order of your spine skeleton. The way that it accomplishes this is rather inefficient right now, but that's okay, because hopefully you don't need many of them. But the general idea is each one of these submesh renderers grabs a submesh from the actual spine runtimes generated skeleton mesh, and disables the original mesh render and only renders the two passes, or the individual pass for each one. So by doing that, you're able to set the sorting order or even sorting layer ID for each pass and push stuff into the foreground or background by also setting the order on the sprite renderer or other Unity renderer. And just to show this is actually doing what I said it was doing, this is a Unity sprite, and it is actually part of the scene graph, but it is underneath the hands and the front arm, but in front of the rest of the body. The way this is accomplished is a couple modifications to the skeleton renderer code that looks at your spine slot setup and identifies any slots that begin with an asterisk. If it finds a slot that begins with an asterisk, it will cause the skeleton renderer to create a new submesh when it reaches that part of the draw order. So this list will change if you set draw order keys, or if you add more than one asterisk, there'll be more submeshes. This list will also change if you are using more than one atlas. So do be careful. Just be careful. There's no easy way to say that. But it does actually allow us to push Unity scene graph elements directly in between spine slots in the draw order. So I'm going to keep going and jump right in here, because this also shows off all of the rigid body constraints, rigid body overrides, and IK constraints for casting against the ground. And I've kind of integrated this all in one big control test. I like to call the sword in the stone test, which gives you a dynamic character that is playing an animation but also running an override on the cape. So this is interacting with the ground as well as running a rigid body simulation that's taking its force keys from the actual animation. But I've also linked the hip as a hip override to a script called hip controller that gives basic control over the hip to an analog joystick or the keyboard that allows you to pull on the character up, down, back, or anywhere there in between, and kind of make your standard animation a little more interesting by giving a very dynamic response to player input. And just to show a little bit more of this working in real time, you could even take the entire background and move it around, and the character would generally react and do ray casting against the ground or keep its hands on the sword, even though the sword isn't part of the spine skeleton. The IK constraints are parented to it through another script that's moving the internal IK targets through additional overrides to the sword's position. Yeah, sorry, that was complicated, but this is more of a tech demo than a tutorial. But there you go. This I thought was a pretty cool test of almost everything I've worked on in SkeletonUtility. And I hope that covers most of it. I don't think I missed anything crazy. I'll definitely be writing some tutorials and giving some more in-depth examples for specific elements of this rather than just throwing everybody off the deep end. Yeah. See you guys soon.